Hello, everyone. We're going to go ahead and get started on section 11.3, which is going to be on measures of average. So as an overview, do you think that you are an average college student? According to various sources, the average college student is a female, 20 years old, lives on campus, works off campus, talks to her parents every day, comes from a family of an annual income between $50,000 and $100,000, sleeps 6 nights a week, has $2,700 in credit card debt, and will finish college with $21,000 in student debt. So, do you think you're the average college student? So, the word average tends to be a little bit ambiguous. It really just means the most typical case in a lot of certain scenarios. So, in this case, we're talking about the most typical, the most common kind of situation to occur, which is the most common college student. So, it's not necessarily that it is a mathematical average, it is just the most typical case. So measures of average that we commonly have probably heard of are the mean, median, mode, and mid-range. The mean, also known as the arithmetic average, is found by adding the values of the data and dividing by the total number of values. So for the mean, we add up all of our numbers and then divide by the number of numbers. So we have the mean here. We say if x sub 1, x sub 2, x sub 3, all the way up to our last data value. These are the data values. N is the number of values. So the mean is the sum of your data values divided by the total number of values there. So that's how we take the mean normally. A lot of the time, though, and what we've seen in kind of our last sections is that there's many different ways to group your data. So finding the mean for group data is going to be a little bit different. Step one, we can find the midpoint of each class in the grouped data. So for every class that you have that is a range, 1 to 5, something along those lines, you're going to find the midpoint of that class. Then step two, you'll multiply the frequency for the class by the midpoint of the class. So instead of finding all of your values and then adding them up and then dividing them all, you'll separate them into classes, find the midpoints of each class, multiply the midpoint by the frequencies. Then you add up all of those products from step two, and divide by the sum of all possible frequencies or the total number of data values. So you're still dividing by the total number of data values. This is just a quicker way of kind of summing all that up as opposed to adding every single individual value together. We have a formula on the side here. If you would prefer a formula for the mean of group data, we say the mean is equal to the sum. That is what the Greek letter sigma means. It means the sum of the frequencies F times x sub m, where that is the midpoint of every class, divided by n, the sum of the frequencies. So there's a formula explanation for finding the mean of group data as well. So there's the formula if you would like to use that. Or you can also just use the steps, whichever you prefer when finding the mean for group data. So, all right, we're going to try out a couple examples. So for our first example, we're going to find the mean of the values. Our values are 2, 8, 9, 13, 16, 19, 25, 31, 37, and 40. Like we talked about before, the mean is the sum of the values divided by the number of the values. So we'll need to add up all of these numbers and divide by the number of digits there are. And we can count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 total values. And then we'll add up all the values themselves and divide by 10. So we get the mean would be 2 plus 8 plus 9 plus 13 plus 16 plus 19 plus 25 plus 31 plus 37 plus 40, all divided by 10. So we go into our calculator, we add all of these values up, and all those values add to 200. 200 divided by 10 is 20. So the mean of all of those values, or the average of those values, is going to be 20. That's a number that theoretically lies somewhere in between your range of numbers. All right. Now we're going to find the mean of these values. Now we have -10, -7, -4, -3, 0, 1, 5, 9, 11, 17, 19, 22. So we're going to find the mean of these values as well. Same as last time, it's going to be the sum of the values divided by the number of the values. So just like last time, we can count up the number of values. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now there are 12 values in total. We're going to add these values together. We see the difference here is that these contain negative numbers in addition to positive numbers. So our range is going from negatives to positive values. So our mean will probably lie somewhere in between, which will be closer to 0. So, all right, putting those together, we're going to add up all those digits and divide by 12. So we'll have -10 plus -7 plus -4 plus -3 plus 0 plus 1 plus 5 plus 9 plus 11 plus 17 plus 19 plus 22, all divided by 12. That equals 60. So between all of those numbers, the negative numbers and the positive numbers, they all add up to positive 60, and positive 60 divided by 12 is 5. And between the values that we see kind of at the ends, -10 and 22, 5 is definitely a lot closer to 0, and that's because we went from negatives to positives, so our average was probably going to be closer to 0. So, all right. Now for our example that we'll do together, we have the data in this table is the number of losses by the team that won the NCAA men's basketball championship for the year 1939 to 2016. We're going to find the mean number of losses. So we have our chart here, we have our frequency distribution. Now we see where we have our classes. So we're going to need to use the mean for our grouped data as opposed to the mean that we've been using so far. So what we have here is that between 0 and 1, there were 13 losses. There between 2 to 3 over 28, or the number between the losses for all the different years. So there are 13 times the losses were between 0 and 1, 28 times were between 2 and 3, 21 times were between 4 and 5, 9 times between 6 and 7, 4 times between 8 and 9, and 3 times between 10 and 11. So we're going to find the mean of our group's data here using what we saw on that last slide there for our information. And so let's go ahead and do that all together. All right, so here's our question again. We have our formula. The mean will be the sum of the frequencies times the midpoint divided by the number of total frequencies. So what we can do is that we can set up, we already have a chart. We can set up kind of a larger chart that will kind of let us work within that chart in order to get the right answer. So we're going to draw this out so that we're going to have our losses. And then we'll have our midpoints from there. Our midpoints, as a reminder, are that x sub m. Then we have the frequency. And then lastly, we're going to have that product of the midpoint times the frequency. We say frequency is that little f. So our last one will be that f times x sub m. So we can rewrite a lot of this data here. So our losses between 0 and 1, 2 and 3, 4 and 5, 6 and 7, 8 and 9, and 10 and 11. So we want to find all of the information in between. Then at the end, when you take the sums of a lot of this information, we know we're going to want the total number of frequencies, and we're going to want the total product value of all of our frequencies times our midpoints. So we're going to have one last kind of row in here for our sums. And our sums are just going to be for frequency and the products. So, all right, so we have a chart drawn out here, and we need to find the midpoints of all of our different classes. So when we take the midpoint, typically what we want to do is add together the endpoints of the class and divide by 2. So that would look like 0 plus 1 over 2. And that's going to be the midpoint. 0 plus 1 is 1 over 2. Let's use decimal in this case. It will make it easier. 1/2 is really 0.5. We'll do this the whole way through. So for 2 and 3, we'll have 2 plus 3 over 2 is 5 over 2, which is going to be 2.5. Then we have 4 plus 5 over 2, 9 over 2, which will be 4.5. We may recognize a pattern at this in this case here that it's going to go by 2s, but just want to make sure that we fill out the rest of our chart. All right, so we have our midpoints. Now we can go ahead. We know the frequencies already. It was given to us in our original table, so we'll fill those in. Frequencies from 0 to 1, there were 13. Then 2 to 3, 28. 4 to 5, 21. 6 to 7, 9. 8 to 9, 4. And 10 to 11, 3. So we want to add the frequencies together because we know that we're going to need to divide by the number of the frequencies. So in this case, this is n is going to equal some number. So we'll go through and we'll add, 13 plus 28 plus 21 plus 9 plus 4 plus 3 will give us 78. So our number of frequencies in this case is 78, so our n value is 78. Now we're going to go ahead and multiply the midpoints and the frequencies. So for each one of these, we'll take our midpoint, which was 0.5. Don't need parentheses on there. 0.5 times 13. That's going to give us a value of 6.5. Then we'll do 2.5 times 28 will give us 70. Then we have 4.5 times 21, which will give us 94.5. 6.5 times 9 will give us 58.5. 8.5 times 4 will be 34. And 10.5 times 3 will be 31.5. So we found all of these values. So now we want to make sure to add all of them together to get the sum of them. So we'll have 6.5 plus 70 plus 94.5 plus 58.5 plus 34 plus 31.5. Adding all of those together will give us 295. So we've completed all of the math at this point. We have multiplied everything together. We found the midpoints. And now we know that the mean will be the sum of the products of the frequencies times the midpoint divided by the sum of the frequencies. So it's important to note at this point that this value here, we already said that this was equal to n, but n is equal to 78. And the 295 was the sum of frequencies times the midpoints. So that is what the value of 295 is, because we added all of those together. So to find our mean, we said it was the sum of the frequencies times the midpoints, which we know is 295. Divided by the total number of frequencies which for us is 78. So we'll divide 295 by 78 to get about, we'll round to 2 decimal places. This should be 3.78 losses. So almost 4 losses is going to be the most frequent in this case, a little bit more than 3 there. So, all right, that's how we compute mean of grouped data. So drawing out the chart is always helpful, having it kind of coinciding with the formula so we can kind of see how everything lines up together, and then plugging our values in there at the end. So, all right, that wraps up example 1. Let's go ahead and go on back to the lecture. All right, so that was a lot of information there about the mean. So now we can move on to the median, mode, and mid-range. So the median, we say, of a data set is the value that is in the middle of all data sets if they're arranged in order. So to compute the mean, really all we need to do is rearrange all of our numbers in order, either from least to greatest or greatest to least. It doesn't really matter which way you choose to do it. Typically, we will always do it from least to greatest together, but you can do it from greatest to least, and the answer will still be the same. So our steps are number 1, just to arrange data in order. If the number of data values is odd, then the median is the value that is exactly in the middle of the list. If the number of data values is even, we have to find the mean of the 2 data values in the middle. So in that case, if there's 2 of them, the mean would just be adding those numbers together and dividing by 2. So that's how we'll find the median if the number of values is even. If the number of values is odd, then it's just the one in the middle. Then we have the mode. The mode is the value or values that occur most often in a data set if it's applicable. If every number only shows up once and none of them show up an additional time, then there is going to be no mode. You are not guaranteed a mode in every data set that you are given, but if a value does occur more than once, we call that the mode. If there are multiple numbers that show up more than once, but they all show up the same amount of times, then you would just have multiple modes. So there can be multiple modes as opposed to things like the median or the mid-range or the mean. There's only one, but there can be multiple modes or none at all. Then we have the mid-range. The mid-range is the lowest possible value plus the highest possible value divided by 2. So the mid-range is really the mean of just the lowest number and the highest number, disregarding all the numbers in the middle. So those are the rest of our measures of average. So together we're going to find the median of these values: 67, 92, 53, 104, 82, 34, and 71. We said to find the median, we need to rearrange our number in either least to greatest or greatest to least. So let's go ahead and order them from least to greatest. So by rearranging, we end up with 34, 53, 67, 71, 82, 92, and 104. Now, what we can do is see how many digits there are. There are 1, 2, 3, 4, 5, 6, 7 digits. Since there are 7, that is an odd number, so we look for the one in the middle, which is going to be 71. 71 we see has 3 digits on either side of it, meaning that it is directly in the middle. So in this case, our median would be 71. So for the median, rearrange. So it's in order from least to greatest or greatest to least, and then it's the number in the middle. All right, so now we're going to find the median of these values: -10, -7, -4, -3, 0, 1, 5, 9, 11, 17, 19, 22. So just like before, we're going to rearrange them. We can rearrange that from least to greatest. So we have 10, -7, -4, -3, 0, 1, 5, 9, 11, 17, 19, 22. If we notice, this is actually already from least to greatest, so we didn't really need to rearrange anything in this case. But of course, we want to figure out how many of the values that there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we have an even number. So now we're looking for the two numbers that are going to be in the middle. Since there are 12 numbers, we're looking for 2 so that there are an even number of digits on either side. That means that 12 minus 2 is 10. There should be 5 digits on either side of the two numbers. So what we'll do is we'll go 1, 2, 3, 4, 5, and the next two numbers are in the middle, because then on the other side we'll have 1, 2, 3, 4, 5. So the numbers we're looking at right now is 1 and 5. So we said before that we need to take the mean of the two digits in the middle, meaning that we add them together and divide by 2. So 1 plus 5 is 6. 6 divided by 2 is 3. So for this set of data points, the median would be 3. All right, now we're going to find the mode of these values. So now we're switching our average here. So here we have 0, 1, 2, 5, 3, 7, 4, 5, 8, 5, 2, 3, 8, 0, 1, 2, 2. All right, even just saying it, we heard a couple numbers definitely mentioned a couple times. That would be most likely 2, 5, and 8 were mentioned a few times. Honorable mentions being like 0 and 1. So those are the numbers that definitely came up a few times, but the number that came up the most was 2. We see that 2 was there 4 times. 5 was there 3 times. 8 was there twice. 0 was there twice, and 1 was there twice. 3 was also there twice as well. But there was only one number that showed up the most, and that was 2. It showed up 4 times. That means the mode was 2. Appeared 4 times there. So in this case, we only had one mode. It was only one digit that showed up the most amount of times. So now we can find the mid-range of these values. -10, -7, -4, -3, 0, 1, 5, 9, 11, 17, 19, 22. Sounds familiar. We have the same kind of range here that we're using a couple times. We said the mid-range would be the mean using the lowest value and the highest value. So in this case, it's already in order, so we already know the lowest value is -10 and the highest value is 22. So since we know what the lowest value and the highest value will be, we'll add those together, divide by 2 to get the mid-range. So we'll have -10 plus 22 over 2. -10 plus 22 is 12, and 12 divided by 2 is 6. So 6 was our mid-range. We actually did find the mean of these values earlier. We found that the mean was 5, so our mid-range was actually very close to the mean in this case. And now we'll do it again. We're going to find the mid-range of the values. 13, 16, 40, 19, 9, 25, 2, 37, 31, and 8. So they are not in order in this case, so we will have to search for it a little bit more. Definitely looking at these values, 40 is going to be the highest value, and 2 will be the lowest. So the lowest value is 2, and the highest will be 40. Now, we, just like before, will add those together and divide by 2. So 2 plus 40 is 42, divided by 2 is 21. So the mid-range of our values here would be 21. 21 doesn't actually appear in this list of values, but we're saying that this should, in theory, be in the middle of all of our values. So that leads us into looking at comparing all of our different measures of average. So all of them have different strengths and different weaknesses, and we can kind of change when we want to use things whenever it's available. So starting off with mean, the strength is that it is unique. There's only one mean for an entire data set. It factors in all the values of your set, and it is easy to understand. The mean is definitely going to be the average of all of the numbers. But the weaknesses is that it can be adversely affected by one or two unusually high or unusually low values. It can also be really time consuming for calculate for large data sets. So it can be really time consuming, and it does get affected if you have a very large or very low value. It will kind of throw everything off by having a value that is extremely high or extremely low. Then we have the median. It divides the data set neatly into two groups, less than, greater than, and is not affected by one or two extreme values, which is nice because we saw that it could definitely affect the mean. But it can really ignore the effects of large or small values, even if they're important to consider. So if you have a lot of data and maybe you do have extreme values, but a lot of it is really high, like much significantly higher, and some of your data is significantly lower, it may not really be taken into consideration that most of those values were higher. It's just going to find the one that was listed in the middle. So it kind of ignores those certain things. Then we have the mode. It's very easy to find. You're just looking for the numbers that appear the most. It describes the most typical case and can be used with categorical data like candidate preference and choice of major and whatnot. That question that we asked at the very beginning, where do you think you're the average college student, that was actually using the mode. We saw that that was just the most typical case. So that was an example of you were finding the mode. It's a measure of average, but it's not the mean or the mathematical average, which is the mean. But the weaknesses of the mode are also quite a few. It may not even exist for some data sets. It's not unique, or it may not be unique. So there could be multiple of them. And it can be different, very different from the mean and median if the most typical case happens to be near a low or a high end of ranges. So it can be wildly different from an average or a mean or a median. And lastly, we have the mid-range. Mid-range is very quick and easy to compute, and it provides a very simple look at the average. But it is dramatically affected by extremely high or low values in a data set. It also ignores all but two values in your set. So it's really only taking into consideration two pieces of what might be a very large set. So we see that there are definitely strengths and weaknesses for every type of measure of average that we have here. And so when it comes to measuring an average for certain situations, we can always try to kind of pick and choose which one would be the best kind of explanation for our data in this case. Unless you're just told which one to use, then make sure to use that one. All right. So our last example here, we have the total area in thousands of square miles of the 15 largest states in the United States are provided in the list below. We want to find the mean, the median, the mode, and the mid-range of the values. Then we're going to try to decide at the end which of the four measures of average would be the best description of the most typical case. So we'll go ahead and we'll do all the different measures of average and then see if we can figure out which one's probably the closest. We have a small data set here. We have 665, 269, 164, 147, 122, 114, 111, 104, 98, 98, 97, 87, 85, 84, and 82. So let's go ahead and go on over to work on this together. All right, so here we have our example. We have our data set. We know we're going to find the mean, median, mode, and mid-range for our set of values here. So let's go ahead and get started with the mean. We know that the mean will be the sum of all of the data points divided by the number of numbers. So if we look at this, we can go ahead and start adding them all together. So we'll have 665 plus 269 plus 164 plus 147 plus 122 plus 114 plus 111 plus 104 plus 98 plus 98 plus 97 plus 85 plus 84 plus 82. There we go, all of our numbers all added together. So we can go ahead and then we divide by the number of numbers. So when we divide, we'll go ahead and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it looks like we're going to divide here by 15. We're going to divide by 15 because I skipped over 85 on accident there, or 87 on accident. So there are 15 digits that we have in total. So we'll take all these numbers and we'll divide by 15. So we can go into our calculator, add all of these numbers together, and we'll end up with 2,327 divided by 15. we're going to go ahead, we're going to round to the nearest whole number. So the nearest whole number would give us 155,133 square miles. So we see here that these values are all in thousands of miles or thousands of square miles. So the 665 is really talking about 665,000 square miles. So if we want to keep this in kind of the format of how we've been looking at all of our numbers, this would still round off to about 155,000. Move this out of the way. Square miles. Actually, we can just do miles squared with that. So this is already in thousands, so this will round off to 155,000 miles squared. So this kind of gives us a little bit of a better representation of the information that was given to us, which was just those three first digits of the 100,000s or 10,000s. So, all right, that gave us the mean. So now we can go ahead and do the median. So for the median, we know this means rearranging our numbers from least to greatest or greatest to least. So once again, it doesn't really matter if you choose least to greatest or greatest to least, but typically we always go least to greatest. But in this case, our data is actually already arranged from greatest to least. We see it is curving kind of around this way. It's going this way and then this way. So this is already in greatest to least. And then it snakes back around there. So if it's already in greatest to least, there's really no reason to rearrange it, although you can if you would like. But instead, we're just going to pick it out of our list here. We know there are 15 digits, so we're looking for the one that lies directly in the middle. So if there's 15 digits, we're really looking for the 8th digit because the 8th digit will have 7 less and 7 more. So go ahead, kind of count this out. We'll have 1, 2, 3, 4, 5, 6, 7, and 8. So our median will be 104,000 square miles. So we have our mean, we have our median. Our next one will be our mode. Since it's all in order, we'll know if a number appears more than once because they'll be right next to each other. So if we want to find the mode, we're looking for the one that shows up the most amount of times. And if we look here, there's only one that shows up more than once, and that's 98. So our mode will be 98. This is in 1,000 square miles. All right, so we have our mean, median, and mode, and now our last one is going to be the mid-range. So lastly, for our mid-range, we take the lowest number and the highest number, add those together, and divide by 2. The highest number is 665, and the lowest is 82. So we'll add 665 plus 82, and this will be divided by 2. So we can go ahead, plug that into our calculators, and we will end up getting a decimal value in this case. So when we do, we'll get 374.5, and then this is once again in thousands. So when we go ahead and plug this in, we're going to round up in this case. You can leave it as 0.5 if you'd like to. Let's just go ahead and round up to 375 square miles. All right. So we'll erase these. We'll leave approximately that value. So we found all of our different measures of average. We found our mean, median, mode, and mid-range. And now we just want to analyze this a little bit and decide which one we think is going to be kind of the most accurate. So if we look, we see that the mean was 155,000 miles squared. 155 would probably lie somewhere. Let's kind of erase all of this here. This would lie somewhere in here, which is very kind of high up in this list if we're really looking at it. So the mean's probably not a great measure of average, especially because of our huge number there, 665. In the same thread, this also counts out the mid-range because we have such a high number there compared to all of our other digits. Even 269 is a lot higher than a lot of the numbers that we saw before, but at least it was still almost within 100, whereas the 665 was just way off. So that 665 ended up really affecting our mean and our mid-range. So these ones are probably not the best measures of average. So instead, let's look at the median and the mode. Our median was 104, which was, as we know, the number that lies directly in the middle. And the mode was this 98,000. 98,000 showed up twice. They're right next to each other, so it's not like one of them is skewed really far over to the side. So at this point, we can probably safely say that either one of them is fairly good. But there is one thing that does make one of them a little bit better, and that is solely because the mode was 98,000, or not just our 98 value there. It just happened to be the number that showed up more often than not. We easily could have not had a mode, or that mode could have been a completely different value. It was kind of more coincidence that it did end up right there in the center. So in all honesty, our median was probably a better measure of our average in this case because it was the one right in the middle there, as opposed to one of the ones all the way at the end. So the mode is still okay, but the median is probably the best one in this case. So it's the best measure of average. And there we have it. So we've calculated all of our different measures of average and determined for a given set of data there, which one was going to be the most accurate. So, all right, let's go ahead and pull it on back to the lecture. All right, and that wraps up our section. So in section 11.3, we learned how to compute the mean of a data set, compute the median of a data set, the mid-range mode of a data set, compute the mean for a group data set, and compare the four measures of average together. So that wraps up section 11.3, and I'll see you in the next one.